This video lesson is an extension on a topic that you looked at last year, the geometric series from the sequence series unit. So the formula that you're seeing first is the sum of the geometric series formula given a certain number of terms, which is where that n comes from. We're going to focus in on what happens when we have a ratio that's in between -1 and 1 and kind of look at the limit or what this formula is going to approach. So we're going to look at an example. R is equal to 1/3, and we're really going to focus in on what happens here. So I'd like you to calculate the following and just kind of see what's happening. 1/3 squared, 1/3 to the 10th, and then 1/3 to the 50th. So at first you see that you get 1/9, then you get 0.000169, so it's getting smaller, and then you'll see the 1.39e -24. That really means times 10 to the -24. And really, what is that saying? You have 23 zeros before, I'm not going to write this out, but before the 139. So 23 of these guys beforehand. Therefore, this is getting close to 0 when you have that fraction there. A little more formal, r to the n approaches 0 as n approaches infinity. So it's the same idea of what's happening when we look at asymptotes and limits. So I'm going to replace in this formula the r to the n with 0. Since that r to the n approaches 0 in this specific case. And therefore the infinite geometric sum formula is s equals a1 over 1 minus r, as long as you have that inequality of -1 is less than r is less than 1. So this formula will work kind of, you have those series that have that ... and it keeps on going to infinity, but you don't have a last term. With the first formula here, you need a last term, or you need to know how many terms you have in the series. With an infinite, it keeps on going forever, and eventually it approaches this limit of the sum in this formula. So we're just going to look at a few examples of this. And we'll try some practice after. In the examples, we are not going to look at any applications, but you will be applying this to some situations as well. So first example, find the sum of the geometric series . 2 plus 4/3 plus 8/9, and then ... So we are given a last term, and remember what you want to look at, we know that it's geometric. I mean, we should be able to also tell that by looking to see if there's a common difference or common ratio. So our first term is 2, that's important. And our ratio we're going to get by doing the second term divided by the first term. So if I do 4/3 divided by 2, I get a ratio of 2/3, or what you would have to multiply to get to your next terms. Since r is less than 1, it's infinite. And therefore we're going to be able to plug into the formula 2 over 1 minus 2/3. Now remember, for your calculator use, it might be a good idea to use the alpha y equals if you have that. There are ways around it, and I usually just put the alpha y equals for this part, and then I just do regular dividing down here, but you could do another fraction tool for that. You can also do 2 divided by and just put the denominator in parentheses. Just as easy to do if you don't have the fraction tool. Both are giving us an answer of 6. So if we don't have that final term, but we know that it's an infinite series, we can use this formula. The next 2 are also finding the sum of the series, so I'm not going to repeat those directions. So here our first term is 1. Our ratio in this case is 1/3. That's kind of an easy one to see. And then again, plug right into that formula, knowing it's infinite because this is between -1 and 1. Last one like this. Here we have a geometric series that is alternating positive, negative. So when you do your ratio has to be -3/4, and that's important for when you're plugging it in to be careful with the negative sign. It's a little easier with the infinite series formula as opposed to the regular geometric series formula because you don't have the r in 2 spots. So 1/1 minus the -3/4. So you're really going to be adding that. And that will also come out to a fraction result. I just have one more example of a situation that you have to be careful with in case it shows up. In this situation, your common ratio, so our first term is 4, you could start off by that, and your common ratio is 2. We need a last term to come up with the sum. This is not infinite because it is not in that range of -1 to +1. So the sum for this would be technically infinite, but it really doesn't exist. You can't find this. So you could put infinity, but you can't find the sum. Without a last term. And there are options for plugging in the formula, but this is a sum that you wouldn't be able to find. There will be something similar to that on the practice, and there will be some application problems that you'll have to use the idea of the infinite sum to solve.